You're going to have to invest your money at some point, I would hope, and you're going to see how much interest you're going to gain by maybe going with a bank or wherever. Okay, in these situations, they're a little bit really high interest rates, which is awesome, but I'm telling you, a bank will not give you that high of an interest rate. But it's very cool to see how your money can compound over time, and that's going to be super important if you ever take out a loan. If you ever take out a loan with like a loan shark in the future because you have this idea and you want them to invest in it, then this is kind of what we're talking about. So making sure that you understand what it means to have an interest rate will be very beneficial when you go and invest your money. So compound interest, we have this formula here, and that P is your principal, which is your initial amount. So that principal, I'm going to go ahead and write that in just so that you have it. Hold on. So this is going to be our principal. Okay, I always spell principal wrong because it's either L-E or A-L-E.
P-A-L is like principal here because he's your pale. So it's P-L-E.
So this one would be L-E then.
L-E.
There you go. Okay, sorry about that. I am not, like the spelling is just not my thing. Okay, then this R is your rate. The N is the number of times in 1 year it's compounded. Okay, so if I say semi-annually, that means twice a year. So N is how much, the number of times compounded. Now again, compounded, what does that mean? Compounded means, okay, after the first year you have this much money, and then you take that money and then put interest on that. And after that full year, it just keeps compounding. It keeps adding up, okay? And then the T is your time, okay? So how many years? So if I ask you how much money you're going to have in your bank in 5 years, that's time. That's not how many times it was compounded. That means the time, how many years, okay? So when we talk about this, when we talk about time, we need to be able to convert, or when we talk about number of times a year, we have to convert to years. So 18 months, how would I convert that to years? Well, if you guys took any kind of science, you probably did some dimensional analysis at some point. Huh? Yeah? Okay, well, how many months are in a year? 12. So all I would do is I would divide by 12. Okay, so what does that reduce to? What would be your fraction? 1.5 years or 3 halves years. Okay, so 18 months is 1.5 years. Because you have to talk about years when you're talking about your time. Okay, you can't talk about months or days. You gotta talk about years. Okay, 100 days. How many days are in a year? 365, technically 0.24, but we'll just go with 365 because there's a leap day, a leap year. So technically it's 0.25, but we won't make you use that. That's science. Okay, science, they'll make you use 0.25, but we won't here in math. So how would this reduce? This is a little bit harder to reduce. What number goes into both of them? 5. So when you reduce both of them by a 5, you get 100 on top, and you get 73 on the bottom. So that's years. Okay, if you use the decimal, it's fine. The only problem with that is that if it's like a repeating decimal or something like that, you want to be as accurate as possible. And that's the most accurate. Okay, let me just double check that. 100 divided by 73. Yeah, so if you look here on your calculator, you're going to get like 1.36986. Okay, you want to be as accurate as possible, and this will give you the accurate amount. This will be a little off. Okay, so make sure you try to use that fraction.
Remember in math class, you don't want to round until you get your final answer.
Yes. Okay, so for 20 months, same thing. What we're going to do, divide by what? 12. And you get what over what? Yep, 5 over 3 years. This one, again, divide by 12, and you get what over what years? Yeah, 1 over 4. Okay, so 3 months is 1/4 of a year. We're going to the second page. Okay, again, that's important because when you're talking about time, you have to be talking in years. Okay, not months or days. You have to be talking about years. So if you've got something where I said 20 months, you'd have to convert it to years. It won't work if you use 20. Okay? So maybe I'm going to come up here and I'm going to put years so that you don't forget. That needs to be in years. The time. Okay? All right, now let's talk about what these words mean. Again, they're going to be super important for you to understand them. Hopefully you kind of already know what these are. I'm not sure if you learned it yet. But annually is how many times a year? One. Okay, that's your N. That's how many times a year. That N is your compound. So if I say annually, that means you're only getting interest one time a year. Something interesting about interest is that the more times it's compounded a year, the more money you're going to get. So annually would not be the most beneficial situation here. What about semi-annually? Yep, 2 times a year. What about quarterly? 4. What about monthly? 12. What about daily? Yeah, that would be fun. So every single day you get interest on it. That'd be awesome. Now it's not going to make a dramatic difference, but you will get a little bit more money the more it's compounded. Okay? So now let's actually try a problem. Freddie deposited $300 into a savings account. Alright. That earns 6% interest compounded monthly. So I'm going to underline compounded monthly. The reason why I'm underlining compounded monthly is because that's going to be your N value. A lot of people tend to not be able to figure out what is being compounded. What's that N? What is our N value technically here? 12. Because if it's monthly, that means every single month my interest is going to be compounded. So what is the amount in his account after 3 months? Okay, so before I even do anything, this is going to be my time. What is 3 months in terms of years? Because before you do anything, I recommend converting it first. How would I write this in terms of years? Yeah, 3 over 12 years, but then that reduces to what? 1 over 4. Ooh, that's supposed to be a 4, not a Y. Okay, because you have to convert to years first. So I would recommend just doing it right off the bat so you don't get confused later on. All right, now let's go ahead and plug it into that formula. I have A of T is equal to, what was our principal? What did we start with? How much money did we start? Yeah, $300. And then we have our 1, that's just part of the formula. Okay, what's our rate? It's 6, but it's a percent. So how do I write that as like a number? 0.06. So maybe I'll write that on top here. 0.06 so that you guys get used to that. You have to convert it to a decimal. So it's a lot of just very tedious work, but it's actually pretty easy. Okay, how many times a year was it compounded? 12. So the 12 goes here. 12 goes up here. And then the last piece is going to be our time, which we said was 1/4. Here you know that 1/4 is 0.25, so that sometimes might be a little easier. So here's where you definitely need a calculator. Because the biggest problem that we see on the test is that like you got all this right, but you typed it in wrong. Okay, this is a hard part to type it in. If you have a not so fancy calculator, you have to use really a lot of parentheses here. So you have to use parentheses here and here. But if you have one that raises it up for you, you might not need all those parentheses. So I'll do the first one with you. Give me a second here. Okay, and you definitely could break it up if you want, but I just like to type it all in. And some calculators are nicer than others, so you just got to be careful. Oh, mine's coming up here. All right, so I'm going to type mine in, and mine turns red once I touch it. So I'm going to type mine in as 300, parentheses, 1 plus, and then in my head, whenever there's a fraction, I don't care how fancy your calculator is, if it's a fraction, I put it in a parenthesis. Makes things a lot easier, just a habit. So I put this in a parentheses, 0.06 divided by 12, and then I have 2 sets of parentheses because it closes up this group, but then it closes up the whole entire group. Because now that whole group is raised to some power, so I'm going to press that little caret symbol, and I'm going to do 12 parentheses. Again, whenever I see a fraction, I just use my parentheses, 1 divided by 4. So I'm going to leave that up for a second, make sure you have it, and then press enter. Okay, so 304.522. So we're talking about money here. So when you talk about money, you're going to want to cut it off here. Okay, make sure you round. In this situation, we don't have to round at all. It just kind of becomes the 5.2. Now, 304.52. Okay, let's talk about this. It makes sense. When you're doing these problems, one of the biggest things that kind of annoys me is like if you got $500 or $800, that's like, you should know that when you're doing interest, you're not going to make that much money off of it. So it should be around the amount that you started with. I should be around 300, which I am. If it's below, then something's completely off. You should know if you got 200 that that's not going to work. The bank's not going to take your money. I mean, that would be fraud, but they're not going to take your money. So you should know that you at least are going to get $300, if not more. So when you're doing these problems, be good mathematicians. Okay, understand the problem. All right, so let's talk about number 5. Lockport Bank pays 3.2 interest and compounds semi-annually on a regular savings account. Iva deposited $1,300 into a regular account for 3 years. So I'm going to underline all the important things here. She made no other withdrawals or deposits during this period. How much interest did her money earn? So what I'm going to do is I'm going to go off to the side and just write all of my variables out. I have P, I have R, I have N, and I have T. Okay, what is P, the principal? How much do we start with? Yeah, 1,300. Okay, the rate, convert it. It is 3.2, but how do I convert that to decimal? Not 0.32, that's 32%. 0.032. If that is confusing for you, you would just have to do 3.2 times 100 to help you out. Okay, if that's something that you're going to keep forgetting, just times it by 100 every time, and it's going to give you the right answer. Okay, or you move that decimal over to the left twice. Okay, how many times did it compound every year? 2 times, because it's semi-annually. That was this piece here. That's semi-annually. And then how much time has gone by in years? 3. So we don't have to do anything crazy like we did in the last one. Okay, so that 3 years is going to be that time. Questions on any piece of that? All right, let's just plug that in. So I have A of T is equal to our initial amount, 1 plus our rate, 0.032, all over our compound, how much it compounds, times our compound again, or up to the power of, and then times our time, which is 3 years. Or you can just put 2 times 3. Sometimes, again, if things are that easy, just to give your calculator a break, if you can just know that 6, it might be easier for you to type in your calculator and not make any errors. So I want you to take a minute and see if you can type this in. Again, you have to know your calculator that you're working with. Some calculators are going to require you to have parentheses in certain spots. So semi-annually means twice a year. Semi-annually. Okay, so whenever you see the word compound, that's going to be your end value. Okay. See? See in time? It's 3 years. Yeah, so whenever you see the word compound, that's your end. That's your end value. In blue here, when you saw that word compound, that should automatically be like, oh, that's my end value. Okay, you should have got something like $1,429.90. If you didn't, please let me know. Questions?
You're not done with the problem.
Huh?
You're not done with the problem.
Why am I not done with the problem?
How much interest did her money earn? $129.90. Because you subtract $1,300. Because
I would
over the
deposit a
3
regular
years-
amount. How much interest did her money earn? Yes, I totally get what you're saying. So yeah, but So this is how much is in my account at the very end. And he is correct. How much interest did her money earn? She did earn $129. But that's a weird question. Usually we won't ask you that. Usually it'll just be how much is left in your account. So if you want to actually be correct, I totally understand. We would do 1429.90 minus 1,300. And you would get 129.90 is how much money she earned. That's a good observation. So each one of those. Good. All right. So number 6. I'm just going to go ahead. I don't think that we really need to waste our time and do another one. I feel like you're kind of getting it. But let's talk about number 7. You deposit $1,500 into an account that earns 7% interest. Find the new account amount. So this is the final total instead of how much interest. After 1 year, if the interest is compounded each of these. So these are all of your N values. All of these are your N. We want you to see the difference between being compounded only once a year, 2 times a year, 4 times, and 12. So take a minute with your group and do all 4 of those. Okay, because that's going to be your practice that you need.
What is 0.07? Is that R, N, or T?
That's none of them.
0.07. Is that the number I'm trying to calculate? It's a normal.
1, 2. I use that.
Okay, so I kind of set up a general formula for you. You just need to replace all of them with the N.
Oh, that's so much easier.
Well,
Thank you, Miss Abel.
well, I mean, that's what you should have been doing, right?
Yeah, but I was gonna do the longer.
You should be setting it up for each
Yeah, for
one.
each one of
4
them.
formulas.
Like, I'm just showing that all 4 of those that's going to be the formula, yeah. When you're done, you can look up and I'll show you what the answers are. If you are not getting these answers, you need to let us know and we will come help you with your calculator. Because that kills me if that's the only reason why you're getting things wrong is because you can't type it in correctly, which is fine. You just need some help.
Oh, Miss Abel.
Typically, it's just a set of parentheses is missing.
Whenever you see a fraction, please put it in parentheses. Just make it a habit.
You're missing a 0 and you're 15 in the formula.
Oh, thank you. I am missing a
Is
15.
that manual?
1, 2, 3.
Trying to do what that's gonna be.
You can check all your answers. If you did not get one of these, let us know.
We're doing 3 figures. You're doing something amazing there, bud.
Yeah, but we're.
And she's just like,
Where's this coming from? And then after this, we're probably gonna start. It's
Okay, so when I walk around, again, a lot of times what I'm noticing is you're getting it wrong because of this guy right here. You're not putting it in fraction form. You have to. If you don't put it in parentheses or make it a fraction, it will be incorrect. Again, know your problem. A lot of you, when I walked around, you were good with the fact that you only made $5,000. Well, no, we should have more than $15,000 in your account. So know your problem. Okay, I should have more than $15,000 in my account. Otherwise, the bank is robbing you, and you need to go there and talk to them. Okay, so you should have more than $15,000. If you don't, something went wrong in your calculator. Okay, a good tip for you, which I think a couple people were showing me this. If you really struggle with remembering to put things in parentheses, whenever you're working with a fraction, you can press alpha in green, and that y equals sign. And look, number 1 is a fraction. You can just go ahead and put that in, and look what happens. It makes it a fraction. So alpha y equals, alpha, the green button here, mine, alpha, let me clear that out one more time. Alpha y equals, and then that first one makes it a fraction, so you don't even have to think about parentheses anymore. So if you get used to that, then either way works for us. But find out which one works for you. Is parentheses, are you going to remember the parentheses, or are you going to have to do that? Either one. All right, moving on to the next page here. So, is anyone here in physics? Have you seen this constant E before? Yet. This E on your calculator. If you haven't, it's coming. Okay? So just like we know what pi is, 3.1415926, blah, 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 blah. Okay, that's pi. Now we have this other constant called E. Okay, because it's going to be a rational number like pi is. Pi is 3.14. And E is going to be just like that, but instead of 3.14, it's going to be 2.72. So, but we have this awesome calculator that has the E in it. If you find your ln button somewhere, that ln, right above it is that E. Okay, so let me get my calculator out so you can see it. Again, if you're in physics, it's coming. No, it's fine because it's really, it's done for you. But this ln button right here in red, right above it is that E. That's what you're going to have to work with here. There's a reason why the calculator is set up the way it is. It's pretty cool. Is that the inverse of this E is ln, which we'll get into the natural log in a little bit. Okay, not yet, but we will be getting into logs soon, which you will need for the SAT. All right, let's talk about this. So when a population is growing continuously, that's an important word. Okay, whenever you see a problem that says like it's continuously growing, you're going to have to use that E button. Continuously growing is what that E button represents. We can model the population with this formula. Same kind of problem here. A0 is your initial amount, or your starting population. R is still your rate, and T is your time. Okay, same thing. Really nothing's changed here, except for I'm going from a P to A0. So in the model, A sub 0, I already wrote that out loud, I guess. A sub 0 is the initial amount, R is the rate of growth, and T is the time. Maybe in years, days, hours, etc. It depends on the problem. So in this situation, we don't really care if it's in days or years. It does not matter. Okay? All right, so what is E? Like I told you guys, it's kind of like pi. Here's pi, 3.1415926. This is going to be your E. Same thing. Okay, treat E just like pi. It's often used in models of population. Also, radioactive decay on substances is why we did decay yesterday. And it also is vital in physics and calculus. So if you're going to plan on taking calculus at some point, which I think a lot of you will, then you're going to have to know how to use that E button pretty regularly. So if you see that word or you hear the word continuously growing, I want you to think that E button, that natural base E. So the population of Fredericksburg, Virginia was approximately $19,360. That's going to be that initial population. In the year 2000, and it grew continuously, like I said, whenever you see this, that's when you know you're using that natural base E, at a rate of 2.9% each year. So what's our rate in terms of a decimal form? Yeah, 0.029. Okay, 0.29 is 29%. So be careful with that. Write a function to model the population. Whenever you're writing a function, you want to make sure that your T is not filled in. So leave T alone. And that's kind of like what happened yesterday. You guys need to leave that value alone when you're writing the function. So let's write this one out. I have A of T. What's our initial amount? Yeah, 19,360. Okay, then we have this E. And it's raised to some power. Well, it's your rate, which is 0.029 times your t. So that is going to be your function. So now you can say, okay, well in 2050, what's the population potentially going to be? You can find that out now. So if we let t represent the number of years since 2000, what will be the population in 2018? So how many years, how much time has gone by from 2000 to 2018? 18 years. So t is going to be 18. You're not going to put 2000, you're not going to put 2018. You're talking about time. How much time has gone by? So what value does your function model give for the population of in 1980? So, wait. Oh, we have to actually do that problem. Here we go. So we're going to do A of 18. We're plugging in 18 for t. I have 19,360 e to the 0.029 times 18. So go ahead and let's plug this into the calculator. I'll do the first one with you just to get used to this E button. Hold on. All right, here we go. All right, so I have 19,360. You have to press the second button and you have to press that LN button to get the E. Now, again, some calculators are fancy and you see how mine raises it to the power. Some does not. If you have on your calculator just E caret, you have to use a parenthesis. You have to. Okay, so if you have something that looks like this, we just go back for 1 second to make sure that you're doing it right. If you have some, don't write this down, just this. You don't have anything raised, you have to use parentheses. Okay, if you don't, it'll be wrong. All right, let's go back. And then I have 0.029 times 18, and I get 32629. Okay, again, know your problem situation. It should be greater if it's growing. If it's continuously growing, it should be more than 19,000. So that makes sense. Okay, if you got something like 18,000, you should know that you did something wrong. So it's approximately 32,629. Okay, I'm going to round it to the nearest whole number because we're talking about like people here. We're not talking about like a half a person. We're talking about people, so we'll round it. So I want you to do the next one. The only thing is I will set it up with you first. So what value does the function model for the given year of 1980? So here's what I'm going to do for you guys. I'm going to tell you kind of a little trick for time. You take the year that you want. So the year that I want is 1980. So I want the year of 1980, and I'm going to subtract it from the year that we know. I know the population of 2000, right? I know the population of 2000, so you have to subtract it. Now the reason why I'm doing this is because in the last one it was pretty straightforward. 2018 minus 2000 is 18. However, in this situation, we're going back in time. So how much time do we go back in?
20 years.
Yeah, 20 years, but make sure you have that negative. Because now we're figuring out before we had. Okay, so before time, back in the day. So now let's go ahead and plug that in. I want you guys to try that one. We got one more left and we're done. Again, the biggest thing is this. A lot of people will forget their negative in this situation. You always start with what you want. I want 1980. And I was given a population of 2,000, so I want to subtract them to get that. All right. When you're done and when you're done only, you can take a look up. Okay, it's going to be approximately, it's what these little symbols mean, 10,839. If you did not get that, did I get it?
I used 40.
Oh, okay. If you didn't raise your hand so you can see your calculator. Okay.
It's pretty easy though. All you gotta do is fill in the variables. It's like
Everyone got that answer?
Did we if we didn't do it? What are we doing for? Yeah, and then Thursday.
Is this your calculator?
Let me come back.
All right. Do the next problem, and I will give you your homework if you get it correct. I lied. Or doing that one together. Use a graphing calculator to estimate the number of years it would take Fredericksburg to grow to 40,000 people, assuming the population trends continues. So we have to go to our graphing calculator. You will need a graphing calculator. It's pretty much impossible to do it without one. And you can do it. It's just going to take you a very long time. So go to y equals. Clear out whatever you have. Okay, so we have to plug into our formula that we created. We created 19,360 with our E to the 0.029, and I'm going to put X instead of T because X is just easier to work with. Okay, so we have that. Now, we want 40,000. We want 40,000. So in order to do that, there's a couple ways. You can go search for it on your calculator, or we can type in 40,000 here, 2, 3, 4, and you're going to see where it intersects. It's pretty cool. Okay, you could, again, just use the table and try to figure it out. Before we do this, though, we're in 40,000. Our window is going to be way off. So go to your window. Window is kind of like trial and error here. So again, my X max, and I shouldn't have really negative population, so I really don't care about that. So I'm going to go to 0 here. Again, you could use whatever you want. You're going to get it, but you have to make sure that you can see the intersection. So the max, so, oops. Let's just put, let's put 500. Let's see if that works. And then the min, again, you shouldn't have negative people, so I'm going to put a 0. And then the max is going to be pretty big because we know that we're going to get at least 40,000, right? So let's put 50,000. 1, 2, 3. Nope. Come on. Come on. There we go. And then our window. So on your Cognitive Tutor, it is going to be asking you to do things like this. Let's go by, let's go by 10,000. 1, 2, 3. And press graph. Yes, we will start doing that soon here. Still thinking. That's my original. Okay, so that intersection right here is going to be that value. Again, you could go to that table if you want to, and you could figure it out, but I have a way to do that. We're going to press second trace. And that intersect button, that 5, that intersect button. So the first curve, let's move it. Where is it at? There it is. Okay, that first curve, let's just put it somewhere on this line. I'm going to go closer to the intersection. Come on. Press enter. And that second curve, go to the blue one here. Come on. Sorry, my computer is not going very well here. There we go. Press enter. Yes, I want to guess it. And you're going to get 25.02. Okay, again, you could have went to your table and scrolled all the way until you figured out 40,000. That's fine, but that's how I would do it. Okay, so go ahead and put 25, and then we'll give you your homework. Approximately 25 years.
Anonymous.